फ्रेंड्स, आज मैं आपको सिखाऊंगा हाइब्रिडाइजेशंस इन मेन ग्रुप एलिमेंट्स. Hybridizations. Hybridization is the mixing of the dissimilar orbital of similar energy to form new hybrid orbital is known as the hybridization. For example, the hybridization of the methane molecule, that is the sp3 hybridization. How to determine the hybridization? Let's that is the central atom in methane is carbon, so their electronic configuration is 1s2, 2s2, 2p2. At excited state, that is the all electrons present in a single electron present in all orbital, that is a four orbitals. Then hybrid orbital, that is a 4 sp3 hybrid orbital is formed in the methane molecule. So hybrid orbital containing the single electron pair with the 4 hydrogens and form the methane molecule having the sp3 hybridizations. Then for finding the hybridizations, we have to first know the valence electron in each main group elements. So just representative main group element we have considered here. Element is first is hydrogen having the valence electron 1, for beryllium is 2, for boron 3, for carbon 4 valence electron present, for nitrogen 5 valence electron is present, for oxygen 6 valence electron, for fluorine 7 valence electron, for helium 2 valence electron, and for the noble gases rather than helium having the 8 valence electron. To determine the hybridization, we have the some rule, that is a rule for determining the hybridization geometry and shape of the molecule from main group elements. First calculate the number of sigma bond formed by the central metal atom. Find the number of lone pair of electrons on the central atoms and then add the total number of lone pair and bond pairs from the central metal atoms. Then if we get the total number of lone pair and bond pair is equal to 2, then having the hybridization is sp hybridization and their corresponding geometry is linear. For example, CO2 molecule, for the 3 electrons 3 electrons pair having the hybridization sp2 and geometry is trigonal planar. Example is SO3 molecule. For the total number of electrons 4, sp3 hybridization having the geometry tetrahedral. For example, methane molecule and H2 molecule. For the total number of electrons 5, hybridization is sp3d hybridization and geometry is trigonal bipyramidal. For example, PCl5 molecule. For this 6 number of total electrons, total electron pairs, that is a 6 having the hybridization sp3d2 and geometry is octahedral. For example, SF6 molecule. For 7, hybridization is sp3d3 and geometry is pentagonal bipyramidal. We also see the remaining rule, that is the lone pair of electron put at equatorial in sp3d hybridization. If we get the lone pair of electrons in sp3d hybridization, for a sp3d hybridization, it is put at the equatorial positions and put lone pair of electron at axial position in case of the sp3d2 hybridization, that is for octahedral geometries. Then for the sp3d3 hybridizations, lone pair of electrons placed at the equatorial positions. And here the some geometries, that is a linear geometry, trigonal planar geometry, tetrahedral, TVP and octahedral. TVP means trigonal bipyramidal and another is the pentagonal bipyramidal. For example, we consider the example of the ammonia molecule. Ammonia molecule in which nitrogen having the 5 valence electrons, that is total valence electron of the nitrogen is 5. Therefore they form the sigma bond with the 3 hydrogen having the 3 sigma sigma bond pairs, and total number of lone pair is 1. So hybridization is equal to lone pair plus bond pair electrons, that is a 3 plus 1, that is 4. 4 correspond to sp3 hybridization by considering the chart number 2. Then for example, xenon O3 molecule. In xenon O3 molecule, the central atom is xenon, having 8 valence electron, like that: 1 2 3 4 5 6 7 8. As I say earlier, that is noble gases rather than helium having the 8 valence electron. Okay, therefore number of bond pair in the xenon, so only sigma bond is considered and not the pi bonds. For in the example, in any example, only sigma bond considered for the hybridization and not the pi bond. Here is 1 sigma 1 pi, 1 sigma 1 pi, 1 sigma 1 pi. So there is a 1 2 and 3 sigma bonds, and there is a 1 lone pair of electrons present. So hybridization is equal to lone pair plus bond pair electrons, which is equal to 3 plus 1, that is the sp3 hybridization having the tetrahedral geometry. So xenon O3 having the tetrahedral geometry. Then next example, IF7 molecule. In IF7 molecule, the central atom iodine having the 7 valence electron. So number of bond pair, the 7 electrons form the bond with the 7 fluorine atoms. So there is a no lone pair of electrons, so that is the total number of sigma bond is 1 2 3 4 5 6 7. So number of bond pair is equal to 7, number of lone pair is equal to 0 on the central atom. Therefore hybridization is equal to 7 plus 0, that is equal to 7. For the 7, corresponding hybridization is sp3 d3 having the geometry pentagonal bipyramidal. Then next example of the I3 minus molecule is the exceptional example because it having the negative charge. And for the if negative charge, we note that if negative charge present on the central atom, then add electrons in the total valence electron. Here negative charge present on the central atom, so we can add 1 electron in the valence electron of the iodine. And if positive charge present, then subtract electron from the valence electron. For example, I3 positive. In case of the I3 positive, we subtract electron from the total valence electron. Therefore total number of sigma bond in I3 minus is 2, and total number of lone pair is equal to 3. Therefore hybridization is of I3 minus is sp3d hybridization having the trigonal bipyramidal geometry. And we know that the rule for the sp3d hybridization, lone pair, if lone pair is present, then it put at the equatorial position, and for the octahedral geometry, if lone pair is present, then it put for the axial position. So this is the sp3d hybridization. So lone pair of electron present at equatorial position. There is a 3 lone pair present at the equatorial and 2 bond pair present at the axial position. So shape of the I3 minus is linear and geometry is TVP. These are the some example for the practice: ICl3, ClF3, xenon F4, SO2, H2O molecules. Thank you for watching video.